meters away, FD is 0.7 meters away. Okay, if you do all that, you end up with multiply that out, get 0.4, take it on the side, you end up with 0.4 over 0.7, 0.57 times FD. If you're quick here, you can just work out, you've got to take that away from 12. If you want to do it properly, do the same thing around B. The clockwise one is now 0.7 FA. These two are both going anti-clockwise around B. Add up to 8. Okay, so that gives you 8 over 0.7, 11.43. Again, do the check. 0.7 is 11.43 newtons, I should say there. Is 12. So that's moment which you've got.
Okay, we're going to be looking at non-perpendicular moments. We're going to be looking at this for a little time, non-perpendicular moments. Let's just see, I think just a few questions that we might need to solve as regarding this. Okay, could you just write this question? Find the moment of these forces. Find the moment of these forces about the points labeled A. Want to see how to solve this kind of questions. Actually, they said using both methods. That's using the moments method, the principal moment, and more vector that we know that we've done before. All right, let's see how it's been done. Then I would explain. Please make sure you stop at every point and tell me the part you don't understand so that I would explain that part very well. Do you understand?
Yes, sir.
Okay. Are you done? Okay, you done writing.
Moments with forces which are not perpendicular pivot are a little bit trickier to work out. Okay, hopefully if you understood resolving forces properly, you'll see that this force here isn't totally trying to turn around pivots. This force is trying to push it in towards the pivot. So there's two ways that we can work out the force here. One is to just take the component of that force, which is pulling in this direction. That's the bit that's actually trying to make the thing turn. Or the other way is to try to work out the perpendicular distance of that whole force from the pivot. And you might think it's a bit split like two different ways of doing it, but what we'll see is that sometimes one way is easier, sometimes the other way is easier. It's handy for us to have both views to which method is working best. So let's have a look at the left-hand one first. There's the diagram again. Okay, so one way to do this is just to take this force and resolve it. So this component of the force is 10 sine 30. We then got 10.
Do you understand how I got this 10 sine 30? Do you understand that? Hello? Hello, are you there?
No.
So I didn't get that, please. Do you understand how I got that? Hello?
Yes, sir.
Oh, please pardon me. This network is something else. Okay, I was asking a question which, before it went off, I said, do you understand how you got 10 sine 30? Hello, are you there?
Yes, sir.
Okay, you know how you got 10 sine 30, right?
No.
Okay, what you just did was we're using, let's resolve these forces into components. So Now, when we resolve these forces into components, now let's watch the way he solves it. You will see a different way. We can solve it. Okay, if this place is 30, what will be this place?
60.
60. Okay. Now this place will be 60. Now, what we want to look for is want to look for this place here. Let's assume at this place here. So this is our opposite, this is our hypotenuse, and this is our adjacent. We're not looking for this place here, but I'm just trying to say this is our opposite, this is hypotenuse, and this is adjacent. We're looking for this one we just drew here. So now if this is x, this angle here, this line here is hypotenuse, that is 10. So what relates we're given 10, we're given x. That would be cos 60 is equals the adjacent x 10. So now x is now equals to x is equals to 10 cos 60, which is already the same thing as 10 sine 30. 10 cos 60 is already the same thing as 10 sine 30. So if we now take the moment from this, if we decide to find, because this is now the force, taking this as the force and this as the distance. So if you are to find this area here, now we say moment equals to F, that's force, times the distance. Now that becomes 10 sine 30 or 10 cos 60. 10 cos 60 times 3. Cos 60 is half, times 10, which is 5, times 3, which is 15. So these are the methods of solving a question like this. So we're just going to watch this again and see how he does his. I guess his is quite different from this also. Do you understand it now?
Yes, sir.
All right. Are you done writing? I want to clean it off.
Yes, sir.
Sine 33 meters away from the pivot. All we've got to do is 10 sine 30 times 3, so then calculator it's 15. In order to do the perpendicular distance from the pivot on this one, what we'd have to do is extend that line, take a perpendicular distance here, so this is a right angle. And we've then got to work out the length of this line D. But we've got a triangle, we know this was 3 meters, so we can use sine to work out how long the line is. This line becomes 3 sine 30. So now we've got a 10 Newton force, the distance D from the pivot, that's 3 sine 30, 10 times 3 sine 30, 15 Newton meters. Obviously, we get the same answer.
Do you understand the second one? Yeah.
No.
Okay.
No,
What I
sir.
just did here was the second one was just expand the line, the 10, expand it until it gets to this place. Now, we are now looking for this D. We're looking for D, we're looking for this area now. Now that becomes what relates opposites. We're giving the opposites over the opposite at this end over the hypotenuse. The hypotenuse is this is coming at this end, so this becomes the hypotenuse. Opposite over hypotenuse, and that gives us D over 3. Now D is equals to 3 sine 30. Now taking moments again from that point, taking moment from there, that becomes the 10 multiplied by this particular part we're looking for, and that's how they got 15. But this is quite more easier than this, because you could just resolve into vector quantities, into component. You could just take your components and get your answer from there. All right, let's look at the second question. I would have to delete those things.
Okay. Agree that this method is easier. So you might say, oh, let's always just do it that way. But here's our second example. Okay, so if we look at finding the component and the distance, this is a ladder which is leaning against the wall. It's 4 meters from the ground to the top of the ladder. There's a reaction force here at 50 newtons. We want to find out the turning effect.
Okay, in solving a question like this, we asked to find this particular aspect. We are asked to find this. When looking for that, we could actually do something. Looking for that, we could actually get the components of this other other side. We have the component of this side. We can get the component of this side. So let's just watch how he does that. You can actually get a component of this side. This is something I guess you can even do. Okay. Now, if this place is 60, what do you think this place would be? Good. What's the reason for that?
Okay.
Sorry? What's the reason?
Alternate angles.
Alternate angles. Beautiful. Okay. If this place is 60, what's the head out? If this place is 60, you know this place will be 30, right? Isn't it?
Yes.
Okay. Now,
Yeah.
can we now find this side? Let's get this side. Is it possible? Can you do that? Can you? We're given, this is opposite. This is hypotenuse, and this is your adjacent. So what relates hypotenuse with adjacent? That gives you your cos theta. So okay, I just wanted to explain the aspect. Let's continue, please.
This force around the pivot at the bottom here. How do we do this? Well, we need to know the perpendicular distance. We need to know the component of the force. So let's have a look at the component of the force first. We're going to need to find this angle in here. That's a little bit tricky, so we're going to do a Z angle right to get that to 60. We're going to take that away from 90 to find 630. And we've got to work out for the component distributed by force is 50 cos 30. Then we're going to work out this distance here. Well, here's our triangle. This is the hypotenuse of the triangle, so sine 60 equals the opposite.
Please observe this. Do you know how he got that? Are you there? Oh, sorry again. I'm so sorry about this. This is okay. I was asking a question before it went off. Do you know how you got this aspect? I guess you understand how you got 50 cos 30 now, right?
Yes, sir.
What about this one, 64 over D? You
Yes,
understand
sir.
that? Okay.
4 over hypotenuse D. D is 4 over sine 60. That gives us the moment is the force. 50 cos 30 times the distance from the pivot, 4 over sine 60. Then we have to notice that cos 30 and sine 60 is the same thing, and therefore we end up with 50 times 4, which is 200. On the other hand, we could have just said, here's the force of 50, this distance here is 4, so the moment is 50 times 4, 200. But with this is a much easier method, so don't worry about it.
Did you understand the second method?
There's not that I come inside. Look at I come inside the gate.
No, sir.
Just remove everything. Just remove everything.
Now look at what I just did.
Look
at-
X.
From here, remember from this place to this side is 4 meters, right?
Yes.
Okay, now this means that this place also is 4 meters. You understand that, right?
Yes, sir.
Okay, then moments is just force times distance, 50 times 4, which is 200 meters. Okay, I guess. Okay, we still have one more to try. No. Let's leave that for now. Now, do we have? Let me check. Was there any other thing I needed to show you before we moved to the next one? Okay. Let me just see if this slide. Let's just see this slide. If there's anything we need to discuss here. Okay, I guess there's nothing. Now, let's come back to solving some nice questions on moment. Let's come back to solving some nice questions on moment. Remember we said that the principle of moment states that if a body is in equilibrium, then the sum of the clockwise moment at any point is equal to the sum of the anti-clockwise moment about the same body. If that's the case, let's take this question, please. A light beam, AB, sits on a two pivot C and D. Sits on a two pivot C and D. A load of 10 newtons hangs at 0.2 meters. A load of 10 newtons hangs at 0.2 meters. At 0.2 meters, from the support at C. Can you hear me now? Hello? Hello?
Yes, sir.
Okay. Now let's, where did you, okay, I will repeat the question again. A light beam AB sits on two pivots, C and D. A load of 10 newtons hangs at 0.2 meters from the support at C. From the support at C. Find the value of the reaction forces P and Q. Find the value of the reaction forces P and Q at C and D. Jesus.